All right, everyone. Hi, it's Dr. Heath. I am going to just talk you through this problem. It's from section 1.2. It's number 11. Just a couple of different ways that you could think through this kind of problem. So here we have a pattern with blocks built with these square tiles, and we have 3 different questions to answer about them. So our first job is to kind of identify the pattern. There are several different ways you could see a pattern here. One way that I see it is by looking at, so it's maybe easier to see on the third or fourth figure, but I see kind of a row of blocks here, a row of blocks here, and a little tail. So this is the third figure. And so here I see a row of 3 blocks, a row of 3 blocks, and a row of 2 blocks. And then I can similarly see a pattern in the fourth figure, right? I have a kind of a bar of 4 blocks, a bar of 4 blocks, and then a bar of 3 blocks. And then if I go back to the second figure, I can see the same thing over again. So I have 2 blocks, I have 2 blocks, and I have 1 block. The first one is probably the hardest one to see the pattern in, but I do have 1 block and 1 block. And then I don't have a tail, but I could see that as 0 blocks, right? So in each of these, I have a long straight bar that's n long, because it's, on the first figure there are 1, on the second figure the long bars are 2, on the third figure the long bars are 3, so forth. And then I have another long bar that's n long. And then my tail on each of these figures is n minus 1 long, because with my fourth figure, my tail is 3 long. On my third figure, my tail is 2 long, so it's 1 less than the other 2 bars. So if I wanted to figure out the 6th figure, which is question A, I might draw 1, 2, 3, 4, 5, 6. And then on the top, I would say 1, 2, 3, 4, 5, 6. And then my tail would have 5. 1, 2, 3, 4, 5. So this has a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 figures. 17 square blocks. Now, question B asks about the nth figure, which we've actually kind of already figured out by finding the pattern. So I could find the nth figure by taking n plus n plus n plus 1. So I've got n plus n plus n, n minus 1. And then I would simplify this expression. So via the associative property of addition, I can rewrite this as n plus n plus n minus 1. And then combining like terms, I have 3n minus 1. And that would be option A here. And we can double check our answer with the first question by putting in 6 for n. And that would give me 3 times 6 minus 1. That's 18 minus 1. That's 17. All right, so part 3 of this question is asking if there is a figure that has exactly 388 tiles. And so to figure this out, we need to figure out, is there a time when 3n minus 1 will equal 338? And so I need to find if there is such an n that makes 3n minus 1 equal 338. And in that case, that n would be the number of figure that would have 338 tiles in it. So here I'll just solve for n by adding 1 to both sides. So 3n equals 339. Divide both sides by 3. I'll use my calculator, or you can try to do it in your head. This would be 113. So yes, there is a figure that will have 338 square tiles, and that will be the 113th figure.